Welcome to our lecture in connection with portfolio analysis. This is a subject for MACAU first sem students. In the last class, uh, last two lecture, we have discussed in detail about how optimum portfolio is calculated by using Markowitz model. This portfolio that we have developed has been taken from equity shares that are listed in the stock market, but only equity shares may not be included in our portfolio. With equity share, we can also include less risky asset like bond. So the question is, can we form an optimum portfolio by mixing up equity share and bond? The answer of this question we can get by using the capital asset pricing model. In short, it is known as CAPM. This model has been actually developed by William Sharp, and later on it was modified or bettered by John Leitner. This particular model is entirely based on the Markowitz concept of optimum optimum portfolio development. Only one bond has been added with it to make the idea clear. In fact, in CFA model, we will get two important things. First one, or rather two important line or equation. First one is known as CML, capital market line, and second one is known as SML, security market line. So we will start initially with some assumptions of the CAPA model or capital asset pricing model. These assumptions are made to make the environment simple. In fact, later on, it can be removed to make it more relevant for the practical field. It is required because it is a dynamic subject, and for better understanding the concepts, some assumptions can be taken which will not ultimately affect the main conclusion that we are drawing from this theory after taking these assumptions. So whatever the case may be, we are now considering what are the important assumptions of the CAPA model. Just go through the slides. The points has been clearly noted here. First one is only two parameters, risk and return, can affect the investment decision. This is actually based on Markowitz model, and Markowitz model right from the beginning has said that an investor will compare return and risk for developing the optimum portfolio. In fact, optimum portfolio is a portfolio where the investor can get maximum return by taking a minimum level of risk, or it is maximizing return per unit of risk. Second point is investors have homogeneous expectation of the return and risk. That means we are not assuming that different individuals will calculate different expected return and different risk. They will apply the formula that we have learned in Markowitz model. They will get the result and they will believe that this is my risk and return, and expectation of this risk and return are also uniform. Third one is all of them will arrive at the same efficient frontier. So if a particular person assumes that E is the point on the efficient frontier, other individuals were assuming that will select the same point. Although while explaining the Markovitch optima model, we have seen that the point will vary according to the type or nature of the risk-bearing ability of the individual, due to which their indifference curves will differ and optimum point will also differ. So, next assumption is investors are rational in their decision making. So, any irrational behavior is not permitted. They will prefer high return at same risk and same return at lower risk. That means this is the actually preference of most of the individual speculator or investor. Basically, all are risk averse. Rarely few exceptions are there when an investor can be a risk lover. So our theory is based on risk averse concept. Next assumption is all investors have identical holding period. Identical holding period means they will hold the portfolio for specified time. Next is condition of perfect capital market. Means there will be efficiency in the perfect capital market, which will make the market perfect. Inefficiency may disturb the result. For simplicity, there is no tax, and both lending and borrowings are possible at a risk-free discounting rate, which we already know. Now, what is capital market line? Capital market line is nothing but an extension of the CAPA model of Markovitch. In CAPA model, already we have mentioned that it is a optimum combination of equities based on risk and return. But now in CML, we are assuming the existence of a government bond which is risk-free security, and we will add this one with the optimum portfolio to develop this capital market line. So this line, any point on this line will indicate that the portfolio consists of one risk-free bond plus risky equities. It has no liquidity risk, means everything will be interest and maturity amount will be paid in time, and government has power to issue new money. Liquidity risk can be avoided. Since it is a risk-free security that we have assumed, which are issued by Government of India, and Government of India has the power of issuing notes, so we can assume that there will be only no liquidity problem. If the liquidity problem exists, government will print notes and circulate in the economy to solve the problem. Since there is no default risk problem or liquidity problem, this particular security or bond is known as interest-free bond or risk-free bond. So we are combining risk-free bond with the risky security. Now, how the combinations will remain? For combining, we will assume some symbols and gradually apply some mathematical concepts to get the result. The symbols that we are using here is first one is RS, means return from optimum portfolio of the share. Then sigma S, risk of the optimum portfolio share. So these two are the optimum portfolio developed by using Markovitch model. With that, now we are coming to the second two symbols which are related with risk-free bond. RF means return of the risk-free bond, that is government bond. Again, there is standard deviation F, which is risk of the government bond. In fact, since we have assumed that government bond has no risk, the risk-free sig- sigma F is actually zero. But for mathematical equation development, this sigma F we will consider. Then next is the X. X will indicate the proportion of 1 rupee invested in bond. Now we are distributing the 1 rupee between bond and optimum portfolio. So what in what proportion will we buy the bond? That is X. That means from 1, if you deduct X, you will get what proportion of 1 rupee is invested in risky share. And last one is correlation coefficient of share portfolio and bond. On the basis of these symbols, in our next lecture, we will try to develop mathematically the capital market line, and then we will interpret it with the help of the diagram. That's all for this lecture. Thank you.